Well, as per our standard that we set already now, what we've been doing is we've been looking at how things are done in decimal. Because once we understand what we are doing, it then becomes easier, much easier now to then translate some of these things that we're doing, some of our actions into binary. So now we have done tens complement, which I'll call the base is 10, so I'll call it the base complement. We've done 9's complement, which I'll call 9 is 10 minus 1, so I'll call it the base minus 1 complement. So now we'll go to what call this binary complement, binary complements. Now what you will see is complements. What you will see is this: whatever we've been doing with the 10 or the base complement is going to be identical to what we'll do with the binary complement, except that now the numbers will be in binary. All right. Whatever we did with the base minus 1 complement, the 9's complement, we're going to repeat when we're doing the 1's complement. All right, let's start with the 1's complement. For 1's complement, obviously we need our numbers to be to be in binary. Let's say, for instance, we're going to say 1011, 101. I'm already jumping into commas, because if you can work with commas, you can work with numbers that don't have commas. So let's say this is that number, and we are going to try to subtract minus 111, 11. Let's say you're asked to do this calculation here in using 1's complement. I'm going to start with 1's complement. What do? We're obviously going to say our 1011, 101, and then we're going to say the commas must be lined up. That's a 111, 111, 11. Okay, first things first, we are going to balance up the bits, particularly for the you could get away with not doing it if the number was the positive one, but for the negative number, you really need to you really need to do the to do the balancing now of bits. Now when you look at this, we still the same. We are now doing 1's complement. We don't want to see the negative, so we complement negative number so we can change it to a positive. The top number stays the same, 1011, 101, and then the bottom number we complement. Every 0 changes to a 1, and every 1 changes to a 0. That's 1's complement, in case people forgot. So this here is 0, 0, 1. Okay, so we add the complement. Now what we do is, that's a 2. Okay, what happens here? That's a 1, that's a 1, comma, that's a 1, that's a 1. We're adding, so 0. This here should be a 2, but our bits should be equal, so this here is our carry bit. This is a base. Remember, 9's complement, what did you do? We added the carry. This was a base minus 1 complement. The rule for the base minus 1 is the same, so we add this carry. We add this carry. Add. I want to say add. I'm going to write add backwards now. I want to say add. Add our carry. What is this? Add the carry, so that we do not add a 1, we add the carry. The carry bit is added to the whole number, so we don't add the 1. We're adding a 1 with the protas here. We're adding the carry to the whole number. What do we do? That is a 1. When you add, we're adding this carry. That is a 0. That is a 1, comma. Am I adding here? What am I saying 0 for? I'm lost there. Why am I saying 0? This is 1, 1. That is 1, comma, 1, 1. Now what I'm saying to you there is that this is what? This will be our answer. This here with the little 2 is our answer. Remember, we can still be asked we could have been given these numbers in other places, and we would have had to convert, because the binary complement, they say use 1's or 2's complement. You first have to convert your numbers into binary. Even if you had been given, even if they'd been given to you in different forms, you'd have to take them. They could have been given to you in gray code. They could have been given to you in anything that can be what, that can be taken into what, into binary. Then you would have to first revert to binary, then you can come and do this. So you can, then they can say this number, give your answer in what, in base 8, in which case your base is about converting to base 8, with what would have to come in. So I'm just showing you how to what, I've done the conversions, so by now you should know how to convert. So I'm not just showing you how to what, carry out these operations, because I'm trying to avoid my videos what, taking way too long, and therefore what, exhausting our patience and attention span. So this here would be our answer. Just to prove we're not allowed to do this, I'm going to do it because as a teacher, I'm going to take the liberty to do it here and say, let's see if we are right. That there is a 1 if we subtract. Yes. That there we borrow, and that becomes a 2. We borrow the base 2 minus 1. That will be a 1. Then that there we have to come and borrow from there. That becomes a 0. When we borrow from here, we left a 0. So we borrow to this. It's now a 2 again. 2 minus 1 is a 1. So far, so good. That there, we have to borrow from what? That one there, what we borrow? 1 set of 2. That becomes 2 minus 1. That's a 1. Now you have to come and borrow here because there's nothing to borrow from there. We come and borrow. It becomes a 2 there. We take away, it becomes a 1. And this one a 2. 2 minus 1 is a 1. Now 1 minus 1 will be a 0. And that one is left as 0. 0 minus 0 is a 0. So there you can see. But we cannot do it here. We have to go through the what? We have to go through the process. All right. So you can see whatever worked for base 9 is working very well for base 1. If you have a carry, you just add that carry. Now, if we are supposed to then say, okay, let's reverse the process and say, no, not really reverse the process, but do bigger number, a smaller number minus bigger number. We know in this case we're not supposed to get a carry, in which case we have to what? Our sum here, we won't get a carry this time. Our sum here will be what? In complement form, we have to complement again and assign a negative number. Let's see if that's going to work. So what we need to do here, we need to say that is 1, 0, 1, 1. This takes time to do, comma, 1, 0, 1. So first things first, standard practice, balance up your digits, so that there becomes 0 there, and then that there becomes 0. What we then do now to say we are supposed to subtract the bigger number, so we know we don't want to see negative. That becomes complemented so that it becomes positive. A negative number exists in what? In its complement form. So what we then do here is that we will then say that one stays as is 0, 1, 1, 1, comma 1, 1, 0, and then the other one is complement. Every 0 changes to what? Every 0 changes to a 1, every 1 changes to a 0, so that's a 0, a 1, 2 zeros, comma, the comma is in position, and then that's a 0, 1, 0. What do? We are avoiding subtraction, so now we add, that's a 0, that's a 2, 1, 0, that's another 2, 1, 0, that's another 2, the comma stays in place. That's 2, 1, 0, another 2, 1, 0. This is a 3. So a 3 is going to be 1, 1. So that's a 1 there. What do you see? No carry. No carry, which we expected. So what does it mean? This answer is actually not. This is actually 1's complement form of the answer. So what do? You need to complement back. Complementing is what? Is back to back. So you have to complement back to get your answer. So this, you have to do the same complement, therefore every and assign a negative, ne? So every, let me use this, I know I'll need this one not rather than that one. Every 0, every 1 becomes a 0, and every 0 becomes a 1, comma 1, 1, 1, and that there is our negative answer. As you can see, the two answers are what? Are very much the same. All right, I'll now do another example. Let's say let me just do a number without commas so people don't really get confused here. 1, 0, 1, 1, 1, 0, 1. That minus 1, 0, 1, 0, 1, 1. These are base 2 numbers, otherwise we'd have to convert. Oh, I already have the minus. I don't need 2. So, what do? The negative number, we don't want to see it. The computer will say 1's complement of that, and it will say first of all balance up the digits, and then now we've got we are avoiding the negative, so we change that negative to a positive, and we now put what? We put down the ones complement version of that. That will be 1 0 1 0 1 double 0, and then on top that one stays the same, 1 0 triple 1 0 1. And then what do? We add these because we're trying to avoid subtraction. Now that becomes a 1, that is a 0, that is a what? That is a 2, that also becomes 2, that becomes 3, that becomes 1. And as you can see, this will then become, because this was a 1, this will be a 2. What does it mean? We have a carry. We are subtracting a smaller number, therefore we have a carry. What happens then is that we need to, it's 1's complement, same way as the what? As the 9's complement, the rules are the same. Base minus 1 complements, you add your carry. Then you add your carry there, and that is your positive final answer. And your answer is, that will be 2, carry 1, that will be 1, that will be 0 0 1 1. That's a 0. I might as well leave it, because the last 0 behind, then 0 behind the number is what? 0 behind the whole number is actually useless. So are we correct? Let's see. This would be 0. I'm not saying do this, you can do it on a piece of paper, but to do this on the actual work will look like cheating. So you can do that in pencil and erase it, but this will be 0. This will be, we borrow from there, that's a 2, we borrow a set, so this is 1 0 is 2, 2 minus 1 is 1, then that was 0, 0 left, 0 minus 0 is 0, 1 minus 1 is 0, 1 minus 0 is 1. Well, I can take from that and make it 2, one set borrowed there, one set of 2 borrowed there, that's 2. Then if you subtract, that's 1, and then that one there is the same. So if you look at this answer, which you should not indicate for us, which you should not show to us, because that looks like cheating, I'm just proving to you that your answer is actually what? Correct. What I will then do is, I need to create a little space for myself. Then all I've proven here is that what? Is that we're basically doing the same thing here. Okay, that's all I'm proving here, is that we're doing the very same thing. I'll move this a little bit. I want to do the same one there, but this time I'll take the smaller number and try to subtract the bigger number. Now when you say 1 0 1 1 1 0 1 base 2, and I say minus, what did I do? 1, no, I had the wrong one. I took 1 0 triple 1. That's the one I'm supposed to subtract now. So I'll bring that a little bit down. I'll bring it a little bit down there, and probably a little bit lower again. And then I'll say I'm subtracting that from 1 0 1 0 again, 1 1. This is subtracting that, so we're subtracting the bigger number. It's got more digits, therefore it's a bigger number. What we then do, we then say we don't want to see the negative. What we do, change that to a positive and complement. So 1's complement, what do we do now? This is what? This is 0 1. Balance up. I didn't show the balancing up. I'm balancing up there. Show the balancing up. 0 1 0 1, and then this is what? 0 1 0 1 0 double 1 0 double 1, and then you are going to, the complement is going to be all 1's to 0's and all 0's to 1's. 1 2 3 1 0, and then now do I really need to put 2's there? I don't really. All numbers are still in binary, but I will only, because I don't want to confuse people. But again, as long as the answer reflects the 2's, I'm happy. Now that there, when you add, is going to be 1. That there, when you add, is going to be 2. That's a 1. That's a 1. That's a 0. That's a 2. And that's a 1. As you can see, there was no carry bit. If a number if you are separating a bigger number, you will not have a carry. What does it mean? It means you have to what? You have to change and complement again the same complement. It was 1's complement previously. You can't mix the complements in the same one, so we have to complement again. That there becomes 0 1 1 0 0 1 0, and then with a little 2. As you can see, that answer and that answer, they are identical, so it means we have not done anything wrong. So anyway, I don't know if that's enough. I only intend, because probably I should do an example with commas. Let's say an example with commas, and then we'll say, all right, let's say we have a number. Let me take a number and given what in different bases. Let's say I have A, E, it's going to be a long number. So this is going to be a long number. Okay, AE, comma, 1 in base 16. It's going to be a long number. Minus, let's say, maybe let me say 37, comma, 875. Okay, this is what base 10, obviously. I can put the 10, I can leave it. It can't be base 8. Why? It can be base 16, yes. But it's not base 16. Why? I didn't put the little 16. So every time it's another base other than what we are accustomed to, base 10. Then we have to put what? Put the base. Now we can do the shortcut method here. We can say A times 16 to the power of what? 0 plus 1. Oh, 1, not thing. This is 0 1 plus E times 16 to the power of 0 plus 1 times 16 to the power of what? To the power of minus 1. Let me do something that is going to make our life easy. I don't want something that's going to complicate our lives. Let's rather have something like here a 4. I don't think that's going to complicate our lives. You will see now why this will make our life easy. This will have been 1/16, which is going to be very tedious. So I'm going to say 4 instead. And then to binary, that will then be equal to, okay, let me first mention that A, E, comma, 4 in base 16 equals 2. Then what does this mean? This means A is a value of 10. 10 times 16 is 160. Plus E is a value of 14. 14 times 1 is 14. 160 plus 14, 174. Plus 4/16 is a quarter, that is 0.25. So together we have 160 plus 14, 174, comma, that's a quarter, 0.25. Now we then come and say what? We then come and say 174. We want to change this to base 2. This will be what? 87, remainder 0. Then this will be, we're dividing, remember, by the base we're going to. This will be 43, remainder 1. This will be 21, remainder 1. I'm trying to remind people every step of the way. This will be 10, remainder 1. And then there, that will be 5, remainder 1. That will be 2, remainder 1. That will be 1, remainder 0. Out of space. Let me, probably I made my initial numbers a little bit too big. Should have foreseen a space issue here. What I'm going to do is I'm going to move this a little bit up. Probably a little bit up. Let me probably do it here. And then say the 2 there will then give us a 0, remainder 1. And our answer is taken up. A reminder on conversion. And then the 0.25 part, 0.25 will be what? Oh, we multiply the decimal part, we multiply by the base we are going to, and we take the carries down. So our carries are taken down. So what do we have here? We have 50, we didn't carry. We have 00 because we carried the 1. That's our 50 times 2 is 100. So our answer there, therefore, if you look now, our answer is what? 174.25 is the same as in what? In binary bin is the same as 10. We're taking this up. 2 4 5 1s, 1 2 3 4 5, 0 at the end, comma 0 1. We're taking this down, and this is our. Could we have done it easier? Yes, we could have said A with a shortcut method. Let me indicate that if we're not inhibited, if we're not restricted, we could have said shortcut method, and we would have said the A, the E, comma, the 4, and we said binary, the biggest bits here need 4 bits, so everything is split into the comma stays, and the 4 is also split into 4 bits. So this here is A, that is 10 1 0. That is 10 1 0. We did something wrong here. Okay, let's double check. 2 there is 8 7 remainder 0. That's 4 3 remainder 1. That's 2 1 remainder 1. Oh, 5 remainder 0. Okay, 5 remainder 0. All right, so now that was the mistake there. So 1 0 1 0. So let me probably the A, the A 1 0 1 0. The E is 14 1 1 1 0, and the 4 is 0 1 0 0. Okay, this is 8 4 2 1 of each. 8 plus 2, there's no 4, there's no 1, that's 10. That's A, that is 14. That's E, that is 4, and that's what? Our binary. You could see that these are redundant. These are actually redundant, they are not necessary. If you look at that 1 0, oh, we didn't correct this after thing, we didn't correct this one. Okay, 1 0 1 0 1 0 0 1 verse 2. So the shortcut method would have taken us there directly. Now if it was base 8, we would have obviously divided the what? The each digit into what? Each base 8 digit into bits of what? Into 3 bits. Alright, so we would have done the 4 2 1. Now we do the other one is 37. We have to, is decimal, so we divide by 2. This is obviously 36 is 18 remainder 1. That will be 9 remainder 0. That will be 5 4 4 4 4 4. 5 will be 10. 4 remainder 1. That will be 2 remainder 0. That will be 1 remainder 0. That will be 0 remainder 1. And the most significant is at the bottom, so we take it up. Therefore 37 comma is equal to 1 1 2 1 1 0. No 1 2 1 0 1 comma. Now the decimal part is 875. 875 is 0 comma. Actually we multiply by the base we're going to, and therefore we take the what? We take the carries downwards. The most significant is the closest, so this is what? 10. This is what? This is 14 15. This is 16 plus 1, 17. Alright, we try again until we have zeros, and that is 0, 10, carry 1, 14, 15. Now we try again, and you see that now 500 will give us a smooth 1000. Okay, and we take this down. Okay, we take this down, and our answer is therefore 875 is equal to 111. The comma 875 is equal to comma 111. So why are we doing this? We are doing this here to what? To remind people of what? Of the basics, the conversions. Now we go and say, but our work is not really that. We've done that already. Our work is to say, when you subtract, we subtract 1 0 1 0 triple 1 0 comma 0 1, and what do we subtract? We subtract 246 246, so it's 246, so it's here, it's 1 0 0 1 0 1 comma 1 1 1. First things first, we balance up the digits. Okay, we are subtracting that one there. What do we then do? We then say we don't want to subtract, so we do 1's complement and we add. Top number stays the same, 1 0 1 0 triple 1 0 comma 0 1 0. Bottom number, all the ones change and all the zeros change. They flip over, 0 double 1 0 1 0 comma 0 0 0. What do? We did this so we can avoid subtraction, so now we add 0 1 0 comma 0 2 2 3 2 2 2 and 3. So obviously those digits are balanced up, so this is a carry. What do you do with the carry? We add. It always happens when the number you are subtracting is smaller. We add the carry to the least significant digit. That is a 1. That is a what? That is a, we are adding 1 1 0 comma 0 0 0 1, 3 zeros and the 1, and that there is our answer. Maybe we are asked to what? To convert this, and we're going to say 1 times, maybe it depends on what you're asked to. Maybe we're asked to take our answer to octal. Maybe your answer should be octal equals to something in octal. Let's say you're told to take, if you say take to decimal, you then say 1 times 2 to the power of 1 times 2 to, we know the drill. But let's say our answer, we have to take it to octal. What we then do is, from the comma, we know that this is what? This is a 3, 4, 2, 1 will give us a 3. The comma stays. These 3 give us 0. These 3 give us a 1. And these 3, with the non-existent zeros there, they give us a what? A 2. So if you asked to give your answer in octal, with the shortcut method, you'd have done that. With the long method, you'd have had to convert this to binary, 1 times 2, 1 times 2, until 2 as your base, until you had to take a decimal, and then repeat this with your decimal. Okay, we've done enough of those examples. I challenge you to actually do that for yourself and see if you're going to do the long route. I may ask you in a test that you must be asked in the exams. Whoever is examining you may ask you to actually do it through the long route and say they don't want the shortcut method. in which case you have no choice but to do it. So let's try the same question, but now we're going to try the small number minus the big number. That is going to be 1 0 0 1 0 1 comma 1 1 1. Did we forget a little 2 here? Very dangerous. We should be careful. So we take this number, we say okay, we are going to subtract 0 1. We balance up already, comma in line, 0 triple 1 0 triple 1, and then 0 1 0 1 0 1 0 1. Okay, probably I'm not comfortable with the spacing here. Probably let me move this part, the shortcut, a little deeper. Let me move this shortcut a little deeper. Okay, and follow suit with the other one. No, because I'm seeing a traffic situation here. With a traffic situation, probably move this a little closer and say, how about the top one also? I'm trying to avoid numbers being squeezed up too much. And then let's say I take this one here and move it just slightly to the left. Okay, I just don't want to cause. All right, now what I then do is we then say this is the number we are subtracting, so we are going to what? We are going to change that by complementing. Okay, what do we do? That's a 0 1 0 1. Every one changes over and every 0 changes over. 3 zeros. Okay, a 1 before the comma, 1 0 1. Then we know that one there stays the same, 1 1 1. The comma stays in place. It's 1 0 1 0 1. Standard practice, please. Good practice. Let's just balance up the digits. Now when you add, this is a 2. That's a 2. That's 1 2 3. The comma stays, but it's a 3 1 1. That's another 3 1 1. That's a 3. That's a 1. Sorry. That's a 1. That's a 0. That's a 1. That's a what? A 1. That's a 1, and that's a 0. Now we didn't have an extra digit, so there's no carry. Rule is this must mean it's a negative number, therefore this is what? 1's complement. We need to convert it back to the original. Okay, remember these are what? They are back to back. The complements are back to back. The complement of 9 is 2, therefore the complement of the 9's complement of 2 is 7, therefore the 9's complement of 7 is 2. They are back to back. So now this is going to be when you complement 1 1 2 3 1 1 2 3 comma 0 1 1, and that there is our answer. If you look, it's identical to that. This is 1 0 0 1 0 0 1 0 0 1 0 0 comma 0 1 1 comma 0 1 1. So basically, I don't know. I think if it's confusing, I'm really not sure where the confusing part is. Probably maybe they will do too much in a session. I don't know. But I will therefore pause it there. I wouldn't want to proceed to what? I wouldn't want to proceed to the 2's complement now. I'll give people a break to try and digest this, and when they are comfortable, we'll come back and do what? And do 2's complement. I hope the session was fun, probably a little bit more engaging, but I hope we understood and we're happy. Let's meet when we do the what? The 2's complement. Ciao.